end user experience matters a lot when we are offering any feature, right? So as long as it is not adding any value, or the person is not having the patience to who will have a patience to sit and watch for 2 hours just to detect where is my face on the photograph,
Right.
right?
So day typically looks like looking at the data, right? Looking data and cleansing of data. So there is a very popular saying in machine learning that typically engineers should be like looking at 80% of the time should be on pre-processing and processing the data, 20% on the building the model. So that could not be overstated, because the importance of clean data is very important. But because it's also they're saying that garbage in, garbage out. If you don't give proper data, you will get a very poor model. So cleaning of data, analyzing data, the most important task, and then experiment. So it's called experiment. People, I mean, machine learning engineer has to focus on experimenting and trying out different parameters. For example, when we build a model, a lot of things goes into a model. A lot of parameters could be there which need to be tuned, which we don't know which set of parameters work best. So a lot of hyperparameter tuning, which is called, and also we don't know which model works for a particular problem. There could be n number of models available. So we have to experiment what is the right model and combination which works well for this problem. So, and of course, the programming part, programming this, all of this. So this is how the day for machine learning looks like. And very importantly, this has to be used by some end user or end customer, right? So interacting with that end customer to see what experience that customer needs, that's also important, because these solutions are not built on silos. For example, we see ChatGPT is the most popular tool, right? Machine learning model, which has taken the industry by storm. So there, the important how it is different is that I think probably they would have done some user experience thoughts and said what way we can make it very easily consumed by people. So that is the differentiator. So that usability and user experience is also very important, as important, equally important as building the model, because we are going to give the solution in hands of the customer. So thinking on those lines is also very important. These are the some different things which machine learning engineer has to take care of in his everyday life.
At the master's level, almost every other institute is providing specialization in machine learning. If you talk about premier institutes like Indian Institute of Science, IITs, triple IITs, everybody of them have have specializations. They even have specializations in terms of, as I mentioned, computational linguistics is one specialization where you specifically enter into the text processing, right? So there are multiple facets like computer vision, text, speech, numerical. So this narrows it much more further, not just machine learning at the master's level, but computational linguistics, right, or a computer vision, right? So this is among the premier institutes. Now even the masters at I did it at Rama University, and it's a deemed university. So even deemed universities are also giving out specializations in masters. So apart from that, you have online classes also, like Upgrad, Udemy, Coursera, also giving a certification courses for you, right? Plus there are training institutes also. Some of the training institutes, they provide 6 months to 1 year courses. Then there are MBA colleges also. So they target the people at the managerial level or at the leadership level. They have programs wherein they give it for, I think, a 1 year program. People who are already in the system, in the corporate world, they can get into the field of machine learning, and they are more of decision making and strategizing the company's roadmaps, right? So they also need to know where can they include this field, right, in their roadmap. So these are some of the courses that is available, right from people who are in the academic side to people who are in the corporate side. As Raghu earlier mentioned, right, there's a lot of non-coding part also to it. So somebody who
Right.
is doing, who wants to code like full time throughout the day, because we'll be looking at the data, we'll be analyzing the data a lot of time. So there's a lot of switch from software engineering jobs. People who are doing software engineering jobs, they are moving to ML, right? So they might get a little frustrated also sometimes, because there's not as much coding as there is in a software engineering job. But if you're really interested in getting to understand analyze the data and understand the patterns, then this is for them. So the misconception that anybody who is a software engineer can upskill and come here, maybe they may not like that job role because of this reason. And there's a lot of data analysis and not that much of programming.
Yeah, definitely. Yes, this is a mix of analyzing data and programming. And also another myth is that common myth I have seen is that machine learning, first of all, it doesn't solve every problem, right? So this is for people who are decision makers, who wants to use machine learning in a particular product or a solution. We should not try to retrofit machine learning in every solution, right? It's not magic. So we should use machine learning in the places where it is really required. So the myth of saying that any product will become jazzy if we add machine learning is not right. So we should use it where appropriate. So this is mainly for the decision makers, or the people who would look to add machine learning in their products, right, or portfolios or solutions. So this is mainly from their perspective. The common myth is that machine learning will solve everything. It will not solve everything. So artificial intelligence is more of a Uber umbrella under which a lot of fields are there, and machine learning could be seen as a subfield of artificial intelligence.
All right.
So yeah, so artificial intelligence is more of like, it includes various fields, like robotics could be one, machine learning could be one. So a lot of subfields are there, and sometimes it's used interchangeably. But actually, artificial intelligence, you can see, is the envelope, and machine learning is one part of it.
People would work on specifically on the image problems, right? So they are called computer vision engineers. And then people like me who are specifically working on the text side, right? So we mostly deal with the text data and we come up with solutions for it. So we are into the NLP part of it, natural language processing. Then there is speech part, right? So like your Alexa and all, the voice is recognized, and it applies machine learning models on the voice part of speech part of it. That's called ASR. Speech recognition, automatic speech recognition, right? Then there is numerical part of it, like banking, right? You get to see a lot of numbers, right? The revenue is this, and then the employee count is this, and then we try to analyze data on that numerical data, right? So these are the different streams of machine learning one could enter into. Things are coming out of experimentation academia into products because of the hardware availability, data availability, and the algorithm availability, right? So earlier, although there was people had come up with algorithms, but then they didn't have the hardware to run it at that scale, right? So if there's a program which is taking like 2 hours to detect something, we would not be using it, right? It still will not be usable, right? So end user experience matters a lot when we are offering any feature, right? So as long as it is not adding any value, or the person is not having the patience who will have a patience to sit and watch for 2 hours just to detect where is my face on the photograph. So these are the reasons why it is picking up now.
The abundance, one is the computing power, as Shilpa rightly pointed out, and at the advent of internet, last 15 years, if you see, there is the social media, with the use of the internet, piercing through the masses, the availability of data is increased, right? So just imagine how much of data we are entering in Facebook or LinkedIn or Instagram every day. So that availability of data has spurred this, because data is crucial for machine learning. This availability of data with the computing power. 15 years back, for example, let's say I want to build a small system where I want to identify the brands of cars. Today, I can go to internet and search different bands of images for brands of cars like Jaguar, Mercedes, whatever. I can get thousands of images, and using that, I can build a model. This was not possible 15 years back, so I had to search around for data. So that is the most important thing, along with the computing power. As Shilpa also pointing to computing power, I think if you see the Moore's law, like if we are seeing the computing power double every year, right? So today, what kind of PCs or laptops or machines we had 15 years back? Today we have immensely powerful machines. What we used to run in a data center, now we can run in a laptop. So that kind of power we have with the computing power. So these two combination have, accounted for the growth of machine learning. Learn mathematics, that is very important. And other important property, I would say, is continuous learning. So learning doesn't, in any field, learning doesn't stop, but especially in machine learning, I would say learning for a person never stops. It has to be continuous. So because every day you see a new model coming up, every day you see a new advancement coming up. So we have to be on our toes always and continuously learn. So that acumen is absolutely required to survive and to do better in this field.
Yeah, so one is obviously the foundations of mathematics, right? Then second is you have to be iterative and learn to take the run the project in an iterative manner, right? Third is get your hands dirty, right? There are a lot of material on the web. Just plan out. There's a lot. The abundance of material is also confusing, right, for the person, which one to pick up, which one not to pick up. So just plan out for a week or for a month. This is what you'll do, and try to complete that before you jump to something else, right? You get distracted by something that comes new. So, but then try to have a plan of this is what I'll study and this is what I'll do. Theory as well as hands-on coding, right? So that's one part. Fourth and most important, try to meet as much as possible, talk to people who are in the in that field. Nowadays you can just connect to anybody on LinkedIn, Facebook. There's a lot of virtual meetups also happening. So for somebody who's in a tier 2, tier 3 city, right, a student, thanks to COVID, in a way, there's a lot of things happening online as well, right? So of course it is different from a face-to-face meeting a person, but then that when you don't have a face-to-face meeting opportunity, you have a virtual opportunity, make use of it, right? Do a lot of hackathons. And lastly, although I did my master's and my internship, I still try to talk to people who were with me, right? So because everybody is solving different use cases in different companies, so the kind of problems I face or I solve here are different from what they are doing. So trying to be in touch with people who are working on it as well, right? Understanding what is the problem they're solving, how they're solving that problem adds to our learning as well.